Welcome to XL Catlin Arctic Live here at the UK Arctic Research Station in Ny-Ålesund on Svalbard. And a very warm welcome to this final Ask Me Anything open Q&A session today on the third day of broadcast on Arctic Live. We've had an amazing day today. The team have been out sampling on the fjord, collecting plastics and plankton samples, and we've been speaking to hundreds of students across the world on Arctic Live broadcasts. This session, timed for North America, is designed to answer any questions you might have about life and science up here in the frozen north. And so delighted to welcome Ellie, who's going to come and join me by the camera, in front, from one side of the camera to the other side of the camera.
Hi,
and we're going to grab some of your questions from the live feed, and also some that you may have submitted in advance.
Yep, fantastic. We've got lots of questions come through, and it's great to see a lot of repeat schools, so schools that have joined us in the past few days coming back with even more questions.
That's
Can't
fantastic.
get enough of you, Jamie. Right, so let's get started with Lawrence Intermediate School in Lawrence in New Jersey, and this is Dan Brennan, Mr. Brennan's class, and we've also got Bermuda High School again, welcome back, and that's Julie Gunter's class. So starting off with Lawrence Intermediate School in
Wonderful.
New Jersey.
Yes.
Have you ever been in a dangerous situation before?
I have been in dangerous situations, most of them born out of pure stupidity, I'm afraid to say. So I think you learn through experience things not to do. But in terms of being in the Arctic, I think one of the things to remember is that you can feel very secure when you're at a research station like this. But when you do leave the immediate surroundings, we're at an international sort of science village, a collection of buildings from different countries, housing scientists and support staff. But you're very quickly out into the Arctic wilderness, and we are very isolated here. If there is an incident and the weather's in, there's no hospital here, there's no doctor here. The nearest doctor is half an hour helicopter flight away in Longyearbyen, and then the nearest hospital would be at least another hour or so on a jet to the mainland. So we're very isolated, and the environment here can be pretty scary. I mean, we've got, in terms of dangerous situations, I wasn't in danger, but I felt pretty scared, was a couple of years ago when we were abseiling into the middle of a glacier, into the middle of a glacier, rappelling. Is the term in the US, and you're 150 feet above a vertical shaft down into the glacier, and sort of standing on top of that, attached to a rope, and prepared to rappel down. That was pretty scary, but great to have amazing field staff supporting from the British Antarctic Survey. Complete professionals, put my mind at ease, and down I went. And
there's a video, a fantastic 360-degree video of that exact sort of descent into the ice on the Digital Explorer website. So do check that out, because it really is immersive, and it feels like the glacier is swallowing you up. Is that what it felt like?
I just don't look down. I mean, when you're standing at the top, it is a black chasm, and you can't see the bottom. So you just don't know how far you're going, and you're just sort of letting yourself down bit by bit. The first bit's a bit dodgy, and then you get onto a nice ice wall and you can walk down more easily. And then it's actually quite beautiful. It's, if you can imagine a Gothic cathedral with those vertical lines and the fan vaulting ceiling, it's a bit like being in a sort of wild ice version of a Gothic cathedral. Something like the Sacré-Cœur in Paris, perhaps. I don't mean Sacré-Cœur at all, do I? I'm trying to
Notre Dame.
Notre Dame, thank you very much. Sacré-Cœur is in Paris, but without the wonderful fan vaulting. So it has that kind of feel to it.
beautiful imagery there, really, really special. And do check that out, and we can maybe repost a couple of photos on our social media as well, so you can see what Jamie's talking about there. What about clothing?
Yes.
Obviously, it's not as cold as expected at the moment, so we're in fewer clothes, fewer layers than we normally would be. But what sort of clothing would you normally wear in the Arctic?
It really depends what you're doing and the temperature you're operating at. So that if you are quite active and you're working, these are great because your sweat can come out and can freeze on the outside. One of the things you don't want to happen is for your sweat when you perspire and you're working to freeze within the fabric.
Inside, yeah.
Or clump together. You would down. People sort of talk about down clothing a lot. Really, really great if you're just walking around or you've got to sort of rest somewhere or you're waiting for something to happen. Not great for working because your sweat will get into all those feathers and just clump it all together. Be walking around with a big ice cube on. Other things, you might have a skidoo suit, which is a sort of big padded overalls, which you put over your clothes already. Those keep you nice and toasty. Different glove systems that you might adopt. Thin liner gloves so you can operate electronics. Big gauntlets, mitts for riding a skidoo. Better sort of, almost ski winter climbing gloves for being on the ropes, going up and down inside a glacier. So it really depends on what you're doing. Toasty boots or plastics if you need to wear crampons.
And it's all about layers, isn't it? So you normally have a base layer, and then which is sort of thermal right next to your skin, and that's usually a wool or a natural fibre or something that's really warm. And then a mid layer which traps some air, and then an outer layer which is the thick padded material or waterproof on top of that. So whether that's your gloves or your hat, you'd have a base layer, then a mid layer. Same with socks, you might wear a thin pair of silk liner socks and then a big thick pair of wool socks over the top. So you kind of have to have double or triple of everything. Double or triple of everything,
definitely. And that also lets you control your temperature much more easily. Say, I've been clearing a runway, so an area of ground that we had on the sea ice, making sure that was flat and the blown snow was levelled off. And you could, it could be minus 20 odd, and you'd then sort of be working quite hard, and you'd take a jacket like this off and just be working in salopettes and a fleece and a base layer underneath. So it really depends what you're doing, and and dressing appropriately for that, and having layers that you can just take on and off.
Brilliant. Fantastic. What about then the research itself? So we've talked about some of the work that we might be doing, but this question is still from Lawrence Intermediate School. What are we actually researching?
That's a really good question. We're researching 2 human impacts on the Arctic environment. We're looking at a process called ocean acidification, and we can go over that. Just let me know any schools on the live chat if you want us to go over that in a bit more depth. And the second thing that we're looking at is plastics. So with ocean acidification, we're both looking at how the pH of the fjord, the water in the fjord, is changing, and also seeing what kind of impact that will have on the marine life up here. With microplastics, really trying to work out how much microplastics there are up here, and also where they might be in the marine environment. Are they in the surface waters? Are they in the water column? Are they in the sediment? Are they in the animals? Are they in all those places? If they are in the water column, are they grouped in a certain area, or are they spread evenly throughout? And then when you start to know that information, then you can start to get a better idea about the impact of plastics, even up here in this seemingly pristine environment.
And so we've had ocean acidification, so there's lots of videos on our channel about more information and investigations about that, and tomorrow is all about microplastics. So we're getting into more detail on the other videos into both of those topics.
Yeah, so if you are interested in microplastics, and especially sort of how you sample in the Arctic, do join us for one of the live investigations tomorrow.
Fantastic, brilliant. Big hello to Columbia INEM School, who've just joined us on the live feed as well. So welcome back. And another question then, moving over to Bermuda High School. This is an interesting one. How do you maintain a healthy lifestyle with respect to diet and exercise in the Arctic?
It can be quite difficult on the exercise front in the Arctic. It really depends what you're doing. It's melted a bit now, so there's an opportunity to go for a run or go for a bike ride, but it's really round in circles. But a lot of the work here, it can be, if you're doing an ice crawl or you're hand winching or you're digging holes in the ice or the snow or whatever it might be, there can be a lot of physical work, exercise involved. You're flattening a run with a shovel and a bit of 4x2. Plank of wood, sorry for those not familiar with some of the slang. And but other times you can be sat on a boat, just going having an electric winch bring up your sampling instruments up and down. There is a gym over here,
yes, there is.
Which is great. And then in terms of diet, we're very, very lucky here to have a very varied diet
Delicious
from the kitchen.
Canteen.
Delicious canteen. It's curry night in the Arctic. Who knew? So we're very lucky to have good food up here, and that helps us stay healthy.
And thinking of diet and exercise in a very remote polar expedition, for example, it's a very different story, because if you're hiking with a pulk for days or weeks, actually you can lose quite a lot of weight just by burning calories, A, doing the exercise, and B, keeping warm. So how are diet and exercise related when you're sort of in a more remote area, in tents and that sort of thing?
Well, I think that's a very good question. If you look at calories as a unit of energy, and you're balancing the amount of energy intake for the amount of activity you're doing. So if you're doing less activity, you're eating fewer calories, and that's a general rule that, for me, that's how food works. And so if you're traveling across the polar regions, if you're doing some polar traveling and you're pulling all your supplies with you, then you've got three things to look at. First of all, you've got your base stay alive sort of calories, operate your bodily functions. Then you've got another whack of calories to keep warm, so your metabolism changes to burn food more quickly, then you use that extra energy to stay warm. And then you've got the extra whack of calories to actually do the very strenuous exercise you've got. So if you're on about 1,500, 2,000 calories a day, you might move you might move to 3,000-4,000 to stay warm. So
that's an awful lot, maybe 50% more doubled, just because of the cold. So that shows you how much energy you're burning, like a furnace, just trying to keep warm.
It's very great. You can sort of, it's very weird because when your metabolism changes, you can get a bar. You can be really, really cold and get a bar of chocolate like this, and you can eat it. And it's a bit like putting gas in a car. You sort of really fill the fuel and you burn it, and you
literally warms you up. Adding a log to the fire. Burst.
And then you might be getting up to 7,000-8,000 calories a day for a polar trip.
And of course, the problem with that is if you're carrying that food, if you're dragging it with you, you need the extra calories to drag the extra food. So then you need extra food, but then it means you need more energy to drag the extra weight. And so you've got to be very weight conscious. Otherwise, you're dragging 20,000 calories of food around with you, which is why the polar explorers eat very, very high calorie rich, even sort of slabs of butter at some times, don't they?
So we had a packet of butter in our soups, so that was really, really great to give it some taste and provide us with those extra calories. Yes, you get onto the joys of Excel spreadsheets, planning these types of things just to get your sort of calorie sort of weight ratios done.
Fantastic. Brilliant. Okay, back to Lawrence Intermediate School, who's asking about food webs. And actually they've asked, what's the lowest creature on the food web and the highest, so that you've seen? What's the sort of largest and smallest?
So the Arctic food web. So we've got if we can move from the algae, so that's the producer, that's the organism capturing solar energy and converting it into living matter through photosynthesis. Then the primary consumer, the types of animals that are eating that phytoplankton, that algae. You've got animals like cocopod and krill, and then from there you've got all the other abundance of the Arctic Ocean, all the way to the top to the polar bear. It's only a few steps. You've got sort of copepod, Arctic cod, seal, and then polar bear.
So that, if you think that polar bear's got to eat an awful lot of, there's only a couple of stages below, so he's going to eat some seals, the seal has to eat the fish have to eat an awful lot of that tiny copepods that plankton in
Lots of them.
Yeah. And the copepods are really this hidden star of the Arctic food web, would you say?
Alongside of it, I mean, they're up there with the krill and amphipods and
that base layer.
That base layer of zooplankton. Zooplankton incredibly important for the health of the Arctic ecosystem. Yeah.
Okay, so then moving over to Bermuda High School. Again, this is an interesting question, which sort of leads us on to what we're talking about tomorrow. How much plastic do you expect to find? It's an interesting choice of words there. We could talk about hypotheses and predictions.
Yes, one could do, and so nobody knows how much plastic there is in this fjord, which is sort of why we're here. And it's a very odd thing, thinking, well, do I want to find plastic? Do I not want to find plastic? And you can almost find yourself thinking, oh, I hope we find a lot of plastic, because that will be a really tragic story and will draw people's attention to the issue of plastics. But that's not what you do think. You come up here, I think, with a fairly open mind and just interested in how much plastic actually is there and where might it come from. And I think that for me that's quite an interesting question. If you think that you've got the Gulf Stream, which is this Atlantic current coming all the way past Florida from the Caribbean up past the coast of Northwest Europe, that there could be plastic particles that started their journey in the Caribbean or Florida or the southeast seaboard of the US and end up being eaten by a copepod, which is eaten by a Arctic cod, eaten by a seal, and into the belly of a polar bear. So badly disposed of litter in Western Europe could end up in the belly. Yeah.
And I think it's interesting that contrast or that conflict between do we want to find plastic or do we not want to find plastic? Because of course you don't want to turn up and find, oh yes, lots of plastic, because that means that the situation is bad. But I'd say perhaps it's a case of we know there is plastic out there, so in a way we do want to find where it is. We want to find the plastic that does exist, we want to be able to find it so that we can help to figure out ways to mitigate it, as opposed to hoping there's no plastic anywhere, because it's unlikely that there's no plastic in the ocean. We know that there's plastic somewhere. We know it's going into the ocean, but then we lose track.
I mean, it would be rather nice if we found a pristine patch of ocean.
It would be.
So I think, but I think it's also to be very, very careful about having expectations
Exactly.
and how that might affect your experimental design. So that's one thing to watch out for in terms of doing science.
Yeah, exactly. Which is why that wording of the question there, how much do you expect to find, is an interesting one. They've also asked at Bermuda High School, what's the journey like to get to Svalbard? That's an interesting one.
I think it used to be very difficult, but one of the most amazing things about working out of Ny-Ålesund, particularly being based in Europe, is the ease of access. Now, of course, that's weather willing, and these things can change incredibly fast. But it's about a day, so a full day, 12 hours travel between London and the Arctic, which means that you can come and do shorter stays. You can come and do quite quickly be up here and be working in a polar environment. Whereas if you're going to some places in Antarctica, you've got to give yourself a number of weeks just to get there.
Just to get there, yeah.
Let alone considering sort of how much time you need to spend there to do your work.
Yeah, and that also means that it's harder to get out again if you need to in an emergency, or certain parts of Antarctica will be cut off and inaccessible for several weeks, if not months. So you can be stranded. Whereas here, it is still very remote, but it's not as remote as Antarctica.
Well, I mean, the flights are easier in terms of there is a short hop, so you can get over the mountains down to Longyearbyen. You then have a commercially operated airport with control towers and everything else.
On your way home at that point.
And then you're on your way home. That's not to say that the weather can't change all that very, very quickly. But you do feel slightly more connected here.
Sure, that makes sense. And so given that we've come to this remote place, and it still, even though it's much quicker, it still takes us a whole day to get up here. Laura, and that's submitted that's from Colombia. Laura wants to know, what was your motivation to join these projects in the Arctic?
Well, that's a great question. I think my motivation is that I had the chance to go to both Antarctica and the Arctic, working on projects, and I think they're just incredible, incredible places. That they are magical, and they're very difficult for most people to come and visit. I mean, I don't know whether you're planning your next school trip to the Arctic or Antarctic, but it's not normally on the itinerary. And for me, my motivation is I want to give as many young people a taste, a sense of what it's like to work here, what it's like to do science here, and what it's like just to live here. Are we allowed to go outside today? I
was just about to say, so the girls from Bermuda have asked if we can go outside and have a view from the station.
Yeah, definitely. It sounds a bit breezy on the windows.
Head back round.
So I put that on my lapel for now.
This one, and then head out.
So just untangling myself and then come out. I'm going to get blown away and then never quite know what's going to happen outside this door. Wonderful, it's actually quite a nice evening. So we've got a view eastland here, down the fjord that we've been talking about, which is Common. You might be able to see just through the cloud at the end a bit of a glacier there, that's Kongsbergen. You might also be able to see a little birdie bit, that's a small glacier, so that would have broken off, small iceberg, sorry, that would have broken off one of the glaciers at the back, and it looks like it's stuck on the bottom here. It's been in the same place for about a day or so. But do remember that the bit of an iceberg, a birdie bit, you see above the water is only about a tenth of the actual iceberg.
How big would you say that is? It's
probably the size of a small lorry.
Yeah.
And then there's sort of essentially 9 other lorries underneath it to give you a sense of the scale of this. And also look around at the UK station. Give you a view down here. Come around. These are the London houses you just scan past. And this is Home from Home. This is the Arctic Home from Home. This is the UK Arctic Research Station. So we've got a storeroom here, which we've turned into the northernmost studio in the world. We've got bedrooms, some sitting room, office space, lab space, just down at the end. So really, really comfortable place to be able to launch scientific explorations into the Arctic. You might be able to see quite a few containers and other buildings behind. That's because we need to be incredibly self-sufficient here. So there's workshops, mechanic spaces, places to have road clearing equipment. Everything needs to be shipped in, and it's easy to forget that we are very, very isolated here. and we need to be incredibly self-sufficient. It's getting a bit breezy as well, so I think, well, let's go inside and see what other questions do we have. Go in here, shut the door. Working in breeze. Thank you very much, Laura, for that question about my motivation for coming up here. I hope that's given you a bit more of a sense about what it's like here. Finally, coming around. Thank you for that.
It's chilly out there, isn't it?
It's a bit nippy.
A little bit nippy. Is that a British phrase? A little bit nippy.
A little bit nippy probably is a British phrase. I probably use them more often than I think I do. So please ask for translations. Either Ellie will prompt me for a translation, or ask for it on the live chat.
Right. So back to the questions on the live chat then. Again from Columbia High School, we've got. We'd like to know if there's any difference in the pH of water in the Arctic and the Antarctic, which is an interesting one.
That is a very interesting one. It's very tricky to answer. In general, you'll find a lower pH in the polar waters, and that's because colder water contains more dissolved gas, so more dissolved carbon dioxide, and that in turn reacts with the water to become carbonic acid, thus lowering the pH, increasing the acidity. One of the other things that you'll get in terms of having sort of a less base and some more acidic ocean is you've got this runoff from melting glaciers and the melting ice shelf in Antarctica. So that's also going to come into the mix. I have to be honest, I can't remember, we have done a little bit of sampling here, but I can't remember what the last pH readings we've had off the top of my head, so I wouldn't be able to tell you off the top of my head about the pH readings currently in Antarctica and the Arctic.
But it is quite a range from up at the top of the field where you've got the fresh glacial water compared to out in the ocean. There is quite a
there will be a range, and again, so we've been sampling a range of sites. So when we'll be doing the water sampling, not only taking it from a range of sites, but also from a range of depths. Which is really important, and putting all these different bits of information together, including the temperature of the water, the salinity of the water, and the carbonic chemistry there to calculate the pH. So different depths, different places, and that will start to give us a picture.
We've got a really interesting layering here where the salt water from the ocean comes up the fjord underneath the fresh water from the glaciers. So you do get sort of fresh water then becoming saline. There's almost a barrier really that you drop through into the salt water below.
Yeah, so in lots of parts of the ocean, what you'll find is that, of course, that because salt water, seawater has on average about 35 grams, I think it's 34.9 grams of salt per litre. So that's going to be denser. And so the seawater is going to be denser. The fresh water without that dissolved salt is going to be less dense, so it's going to float on top of it. And that line in between those two layers of water is called a halocline. Basically, this means salt line, and that just delineates, separates those two layers of water in the ocean. Then you get mixing and everything else and different currents, but you can see quite a sharp halocline in parts of the fjord here.
Sometimes it's very clear that you can even see if you're scuba diving, it looks like another surface of the ocean under, so you're already underwater and then you see what looks like the surface of water. It can be very confusing if you've been underneath as a diver. You come up and you think you've come up the surface and you're in air, and sometimes divers will take their mask off thinking they've surfaced, and actually it's just fresh water and the real surfaces are even higher.
Wow.
Really strange optical illusion that kind of goes on there. So it really is quite a sharp divide there. Brilliant. Right, so on to W.B. Simpson Elementary School in Camden in the USA. Oh, this is a good one. Who can become an explorer, and what do you study for that?
Everybody can be an explorer. You don't need to come to the Arctic. You don't need to go to the jungle or these traditional sort of exploratory places. I think being an explorer is a state of mind. I think it is about being curious. I think it's about spending time in the outdoors. I think it's learning to observe and record what you see and be able to share it with other people. And I think there are some forms of exploration where you do need specialisation and you do need training. One of those is polar travel. And you can learn how to do that through apprenticeships. In the UK, you do an apprenticeship with BAS, with the British Antarctic Survey. I'm not sure in the US who that be with, but I know that Knowles is a great organisation for getting young people into the outdoors. You can be a scientific explorer, so you can learn how to explore the planet and share what you find through science. And
that's the best kind of explorer, isn't it?
It is. It is one kind of explorer. I think the marvellous people who write literature or share through photography and other things have a way of communication. But definitely, if you want to add to a codified body of knowledge, structured body of knowledge, then the scientific method is definitely up there. And to do that, some really simple stuff. Listen to your science teacher, work hard at science, keep on pushing, the geographical science as well, all the way through your electives at high school and into college and your degree system, and then eventually, if you want to become a professional scientist, then taking that through doing a doctorate at university, sort of PhD.
It's also worth thinking about when you have explorers who are not scientific explorers, maybe they're going somewhere very remote or they're setting a record for endurance, that sort of thing. Quite often they get bombarded by scientists saying, oh, well, if you're going there, can you get this information for me? So I think a lot of explorers become scientific explorers sort of inadvertently, because if they're going somewhere, they might as well take the opportunity and gather data. And it's sort of only right that they bring back some information of a scientific type for us as well.
Yeah, I mean, that's very true. I mean, to understand our planet, you've got two sets of skills. You've got those access skills that you're talking about, which you often associate with explorers, for want of a better term. And they can facilitate access. And if it's tricky to take a scientist with you, then you might be able to do science on behalf of a science team or an individual scientist. So very much, codifying our approach to finding out more about the world using the structure of science is great. It's been a good 100 years or so since we could just wander, in terms of adding to a Western body of knowledge, wander through parts of the world and say, oh, look, this is what we found. Now, I think we need to be much more structured in the way we approach that.
Sure. And talking about access and sort of going off on these epic trips, the girls at Bermuda also want to know what mode of transport do we have while we're out in the Arctic, and how do we get around?
Yeah, that really depends on what you need to do. You might have sort of heard earlier how we fly into Ny-Ålesund on a small plane. To get around, a couple of ways. If you're doing glaciology work and some of those glaciers that you saw behind us when we were outside, that might be by skidoo, by snowmobile. And then if you're doing marine work, it's probably out, on a boat and deploying instruments over the side of a boat. You don't really get the sea ice being thick enough here to sort of walk out or skidoo out onto the sea ice and drill a sampling hole and sample in that way. So it really is going out in a boat or going up by snowmobile.
Brilliant. over to Rochester School in Columbia now. So they've asked what keeps you motivated. Now you've already answered a question on what motivated you to come out here. So let's answer this one in a slightly different way of what keeps you motivated sort of once you're out here, I guess.
The humour. I found polar and remote expeditions quite suit my it's normally quite dry and dark humour, which I quite like. So that keeps me motivated because you end up having quite a good laugh. So what keeps me sort of motivated is dry, dark humour and chocolate biscuits.
Brilliant. And we're very lucky here that we've got some good biscuits at the station.
I've got some very good biscuits, yeah.
I think I've eaten more biscuits in the last week than I have in the last year.
There we go. I mean,
brilliant. Students also still at Rochester School in Columbia are asking who is supporting this expedition.
Wonderful. We've got some great supporters. We've got Axel Catlin, who's been a wonderful supporter, both of our Arctic outreach through Arctic Live and the Frozen Oceans resources, and that's part of the Axel Catlin Oceans Education Programme. And they're now supporting the science up here this year as well. Also supporting the science, we have the University of Exeter and Plymouth Marine Laboratory. That's 2 research teams in the UK. We have the British Antarctic Survey, who support us coming up here in the operations of the UK Arctic Research Station where we are. And this research station is being funded by the Natural Environment Research Council, and that's one of the UK research funding bodies. So there you go, you've got 5 organisations involved in funding this research, and a big thank you to all of them.
And it is often the way, isn't it, that research trips like this are funded by multiple different countries, perhaps, or different institutions, and some of them may be academic, and some might be private, sort of industry specialists as well. And you get multiple funding sources all working together to fund the research. Yeah,
no, and it's really great to have that level of collaboration, and international collaboration is a big feature of science, and it's not about who winning and that kind of thing. It's really about, this feels like this very collaborative endeavour to find out more about our changing planet.
Everybody has the same end goal. They're kind of working
I
together.
mean, your research projects might be quite independent, so that's why I said sort of maybe there. But you might have come up and done some pH measurements in the fjord. We've got standard sampling stations, and you might have come up last year as part of a different project and said, well, I need to go measure that. And then we could use that data, and then they might say, oh, have you been up this year? And I said, no problems, you can swap. International scientific data swapsies. Welcome to Nielsen.
Brilliant. And so talking about that then, let's imagine we've all swapped our data. How long does it take for the results to be published?
It really depends. I think from field to paper, published paper, I think is what we're talking about here. Normally probably a period of 12 to 18 months. Because you can do your analysis, you can do your write-up, but then there's also the peer review process where you're submitting your paper to a scientific journal. Essentially, that's a collection of articles, papers, a bit like a magazine in some ways. But before it can get published, it needs to be checked by other people working in the field.
So you can't just run home and publish your data and say, look what I found in the Arctic. You have to allow other people to check your method and to ask questions and to make sure that what you've done was correct or was accurate, and whether or not they think you've got enough samples, that sort of thing. And that's quite a long process, isn't it?
Certainly, and there are other ways which you can share your data. So there are sort of open data portals. So that means there's an online sort of portal where people can feed in their data, and that can be aggregated, and that's quite interesting. So there's lots of different ways that scientists can share, and it's a big part of science is sharing your findings.
Absolutely. Brilliant. So thanks for those questions. They were from W.B. Simpson Elementary School. And what about questions from David Leader Middle School in Ontario? What are some examples of the challenges that you've had to face while being out on an expedition?
Some of the challenges. I mean, I think great to have you beaming in from Ontario. I think that, I mean, talking about the Canadian high Arctic, the first night I slept in the Canadian Arctic in an unheated tent, the temperature was -55 Fahrenheit, and that by all stretches of the imagination,
that is a bit nippy.
It's just a bit on the cold side, really. So the cold could definitely be a challenge, and it's cold that over the weeks just makes you sort of hurt. It just hurts to be at those kind of temperatures. I'm not quite sure. You probably have the sort of -40s sometimes in Ontario, but that hurts for an extended period of time, and especially you don't have a heated tent because of the potential for carbon monoxide poisoning. So that's the cold is a challenge working in the Arctic. The cold, shock horror. It's challenging when it's cold. Things break, tempers fray. So kit breaks, your humour breaks, which is why I come back to this idea of humour. Humour is so important. And then the final straw was our wonderful Inuit camp dog Tuk, who was our polar bear guard dog. Because the snow was so deep, we couldn't use sort of ordinary tent pegs. So we used bamboo, but it went down quite a long way into the snow. Tuk thought bamboo sticks were the best.
Yeah,
absolute best to go and play with, which did mean that you could end up with half your tent blown away. So we had to resort to putting Tabasco on the end of the bamboo,
poor Tuk.
Well, Tuk tasted one and discovered that
learned his lesson.
learned his lesson that our bamboo tent pegs were not to be messed with. So that's another challenge. Very over enthusiastic polar bear guard dogs walking off with your tent poles.
And for anybody who's worried about Tuk there with his Tabasco bamboo, this is the same dog that you built a dog-loo, an igloo for the dog.
We built a dog-loo.
Yeah. So he was very well taken care of.
Yeah. Tuk was very well taken care of. I think very, very happy. Was supposed to go and patrol for polar bears, but often found sitting by the kitchen door. It being the warmest door. The kitchen door, just to say, the kitchen was a tent. We didn't have a sort of a vast building in the middle of the Canadian Arctic. It was a tent up on the sea ice.
Probably wanted some meat to go with his Tabasco.
Probably.
Yeah. Okay. Brilliant. Good question there. Right. So then, what about? Another good question. What's your favourite environment for an expedition? Bermuda, Antarctica, the Arctic. You've been to a lot of different places, but what's the best environment and why?
The best environment is a group of passionate and humorous people. And I don't really care where that is on the planet, except for jungles.
What's wrong with jungles?
What's wrong with jungles? Lots of things. Clues in the rainforest for a start. It rains.
Yeah, you don't like the rain, do you?
No, and it's been raining here. It's a bit like sort of northern Scotland live rather than Arctic live. And there's things that bite you. I don't like snakes.
Yeah.
I don't like scorpions. I don't like spiders. I don't like all that creepy crawliness.
That's why you like the Arctic.
Perfect.
No insects here.
I think there's one. There's one insect which I've seen since we've been here.
Spotted the one.
I spotted the insect, but by and large, all those little bitey things and things that burrow into you and all that kind of malarkey.
Yeah, that's the fun of it, though, isn't it?
No. I love anyway a great team most importantly, and I have a particular soft spot for the polar regions, the Himalayas, and weirdly the coral reef, because there's nothing that can bite you there. But it's so bonkersly beautiful. It's like a sort of like a really mad granny's rock garden. When you go under these, it's all these different colours and all these different shapes and sizes. It's wonderful.
Like a kaleidoscope down there. So that you're willing to forgo the
sharks and the jellyfish and everything else just for that.
For the colour of the
definitely.
Okay, fantastic. Right, so back onto the live feed. I've got a shout out to Jeff Cruz, who says hi, Jamie.
Jeff, hi, how are you? Jeff is a part of the Digital Explorer team, and it's been great having you support us from Montana. So hope all is very well out there, and great to see you online.
Brilliant. And Jonathan, and this I believe is from Colombia, forgive me if I'm mistaken. Jonathan would like to know if global warming affects internal structures of the ice in the Arctic. It's a very scientific question there. So I'm assuming you mean sort of the crystal structures, the formation of ice layers or different types of ice, because there are different types of ice and snow, aren't there?
If we get a clarification on that.
Yes, Jonathan, can you...
There's various bits of ice that I'm comfortable talking about. I've been on sea ice, and I've been inside a glacier, and so there's a few bits of ice we can talk about, but Jonathan,
clarify
get back to
exactly
us.
What you mean by that, because there's also different types of snow you were talking about earlier today.
Jamie I got very excited. I get very excited by squeaky snow. And had the pleasure of being up here 1 year with someone, Blair, who has a PhD in snow, and snow makes different sounds as a crump. So something like crump, 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 and then sometimes it's very squeaky when you walk on it. And I can't remember exactly now, but he's telling me about how snow forms and the different temperatures and the different density of snow, and how it then makes the different noises. And you can tell a lot by the sound of walking on snow. It's
That's
absolutely
fantastic.
fascinating.
So that sound and sort of a different way of measuring the type of snow. So maybe you can go and find out more. Back in your classrooms, go and find out some more about different types of snow and ice.
Squeaky snow.
And Jonathan, hopefully that will help you to find out some answers to that question of yours as well. So we're running out of time here, so we're going to answer a couple more final questions. Laura, I think it's the same Laura possibly who asked the first question. What support, this is a good one, what support have you got from political organisations or the government to conduct your projects? What support do we have? I mean, we have the UK Arctic Research Station, which is a taxpayer funded sort of building. So this is great. It's a publicly funded building and resource for the Arctic. So that's really great. In terms of political organisations, I've sort of stayed a bit clear of politics. What I'm focusing on at the moment is this mixture between science and outreach. So how young people can understand the process of science in the Arctic a little bit, about working scientifically, a little bit about the sort of wonders of this region. And then also maybe thinking about careers or thinking about what they can do to preserve this. And I know there's some politics involved in that, because you might be asking your representatives wherever you are to say, well, what are you doing or what actions are you taking to preserve parts of the world like the Arctic? So that's certainly a step you could take. But as in collaborating with political organisations, that hasn't really been a huge part of the work we do. It's important that, so a bit like we were talking about with the funding, it's important that the science isn't biased in any way, and so it's more the scientist's job to collect the data and provide it to different governments, and then there are other people that can come in who are experts and lobbyists and so on as well, who can help to use that data to discuss with the governments what to do with it.
I mean, I think you can look at impact, and we talk a lot about science impact, and so you have impact in one way in which you're adding to the body of structured scientific knowledge about the world. We talked about peer-reviewed papers a bit earlier, but you also have other pathways to impact. And in the UK, we have three, and for the National Science Foundation, which I think is one of the big funding bodies in the US, they're starting on to look at these types of areas too. So we have commercial. So is there a commercial impact? So for instance, if you develop graphene, then there's a commercial piece there. we're working with another organisation, Oxbotica, who are developing autonomous vehicle software, and so that came out,
commercial value,
and that came out of university research. You then got policy, so that's what I think we may have been alluding to. So does your research help to inform policy? And most famously, research done, for instance, on the effect of thalidomide on pregnant women. Teachers might remember that. And then more recently, the research team we're working with and whose members have come up to the Arctic to help with the plastics research. Their work helped to inform UK government policy, leading to a lot of great legislation looking at reducing the impact of plastics on the environment, whether that's a ban on the microbeads or a 5p charge for a plastic carrier bag at the supermarket. And then the third way is then public understanding. So whether that's through an education program like Arctic Live, potentially a museum exhibition, a documentary, those types of things. So I think more and more science is thinking not only about academic impact, but that sort of wider impact as well.
Brilliant, fantastic. Final question, because we have run out of time. Last question, very quickly, good one to finish on. What would you advise our young ones who think that science is too hard or boring? How can you think science is boring?
I can remember thinking science was boring. I can remember wondering sort of why I was doing certain things in science. And for me, context is massively important. So I think it's very easy if you're working, I can remember sort of decades old, sort of like textbooks. If you're working from a textbook to forget that what you're learning has real world applications. So everything from understanding how food webs and ecosystems work is really important to be coming up here. And we have resources to help you explore science through our expeditions. We've looked at forces going down in submarines. If you get that bit of science wrong, then people die. There's a huge range of ways that you can do it. Chemistry is absolutely fascinating. How the world is just innately fascinating, and it's a massive challenge. I think talking to a lot of teachers and educators around the world, that they are under a lot of pressure to deliver test scores, and the natural curiosity they want to imbue in their students kind of get sidelined, and we're trying to support teachers do those two things at once. So science can be amazing. It can be hard. Even the best scientists find it hard and scratch their heads at problems for years and years and years. But it is fascinating to work out how the world works. And I think we're all in a joint enterprise of bringing those really cool contexts from being out in a boat in the Arctic, to being on a reef, to working in submarines and a whole host of other things, to provide that real world context in classrooms. Bring it to life.
And I'm sure a lot of teachers can relate. I used to teach as well, and can certainly relate to that pressure of having to get test scores and having to finish a syllabus and that sort of thing. So it's great to have so many teachers joining us and giving up their precious classroom time to really share in this expedition, bringing science to life.
Yeah, brilliant. So please do carry on joining in on our live broadcasts. We're looking to do more and more, and we just love to bring sort of real science from the outside world live into your classrooms as much as possible. So thank you so much for joining us today, and very much looking forward to you potentially joining on the next 2 days. Tomorrow we have a microplastics investigation, sampling in the sea ice. We have an interview with Nick Scott, who's a master's student just at the beginning of his scientific career. And we also have Ask Me Anything open Q&As here from the Arctic research station here in Yolsund. So lots going on. And then on Thursday, a focus on ice, and then science communicator Ellen McKay joining us for that as well. Thank you so much again for being part of this live broadcast from the UK Arctic Research Station, and it's a goodbye and good night from us.